Hello everyone, in this video we cover all the numericals related to the batteries. Means we calculate how much heat is generated in the battery or how long the vehicle is run once we charge the battery, how much energy is lost, all we calculation done in this numerical section. So let's start. So here is the first question. A lithium ion battery and a EV means electric vehicle has the following specification. So nominal voltage is 400 volt, internal resistance is 0.05 ohm, then discharge current is 150 ampere and discharge duration is 1 hour. So first we calculate heat generation inside the battery during the discharge. Second is, if the battery efficiency is 95%, determine the total energy lost as a heat during the discharge. And third we calculate, assuming all the heat generated needs to be dissipated, calculate the required heat dissipation rate in a watts. Let's calculate all the answers of these three sub-questions. So first calculate the heat generation inside the battery. So formula for the heat generation is heat. Here is the first sub-question we solve. So heat generation is equal to I square RT. This I is nothing but the current. R means resistance and T means time. So the discharge current is given 150 and square. This I square means 150 square. R means resistance. So internal resistance is 0.05 ohm. So 0.05 into T. So T is given in hours, we converted into seconds. So how? This 1 hour is nothing but 60 into 60 seconds means 3600 seconds. So we write here 3600. Now when we calculate this calculation, we get 4050.123. Now this is the answer, or we write in short this 1 2 3 4 5 and 6, 4 into 10 raised to 6, or we write not this 4, 1 2 3 4 5 6, 4.05 into 10 raised to 6. We move a decimal point at the left 6 times. So we write here 10 raised to 6, and 10 raised to 6 is nothing but 0.05 mega joule. This mega for this 10 raised to 6 and joule is the unit of the heat. So this is the final answer. So 4.05 mega joule heat is generation. Now we calculate the second sub-question. So second sub-question is, if a battery efficiency is 95%, determine the total energy lost as a heat during the discharge. So formula for this energy lost is equal to 1 by eta into total energy. This eta is nothing but the efficiency. And efficiency is 95%. So this 95% means 0.95. So here we write 1 minus 0.95 into total energy. Total energy is nothing but the V into I into T. This is the formula for the energy. Again V means voltage, I means current, T means time. So this 1 minus 0.95 is 0.05 into this V voltage. So nominal voltage is 400 volt, then current is 150 ampere, and the time is 3600 seconds. So we write here 400 into current is 150 into 3600 time. So calculate the equation, we get 10 800 1 2 3. So this is energy is measured in joule, but this is the large number we converted into a mega again. So we move 6 times decimal point at the left. So 1 2 3 4 5 and 6. So 10.8 into 10 raised to 6 joule is nothing but the 10.8 mega joule. Now the third sub question is, assuming all the heat generated needs to be dissipated, calculate the required heat dissipation rate in watt. So let's we calculate. So the formula for heat dissipation rate is equal to heat generated divided by time. Here we calculate the heat generation, but if the heat generation we not calculate, then use the formula I square RT. So if you here the heat generation is we calculated, so we directly put the value, and if heat generation we not calculate, then use the formula I square RT, and this time is also T. So T get cancel, only we get I square R, and by using this I square R you calculate the heat dissipation rate. But now here heat generation we calculate how many heat is generated, so we directly put the values. So this is nothing but this 4050123 divided by time is 3600. We calculate here in seconds, so we get the answer is 1125. So I hope all you get idea how to solve the example. Now we see the next question. A EV is equipped with a lithium ion battery pack that has the following specification. So first is battery capacity is 75 kilo watt hour. So we converted into a simple watt hour because we not count kilo. This is 75 into 10 raised to 3 means 1 2 3. We converted this kilowatt hour into watt hour. Now battery heat in 500 kg, then nominal voltage is 400 watt and maximum discharge current is 200 ampere. So first we calculate the energy density of the battery in watt hour per kg. Then determine the power density of the battery in watt kg when the delivering maximum power. Then calculate the C rate when the battery is discharging the maximum current. And last, if the vehicle consumes 20 kilowatt on an average while driving, calculate how long the vehicle can run fully charged battery. So let's we solve it. So first, for calculating this energy density, formula is energy density is equal to energy divided by weight. this energy is nothing but the capacity. So here the capacity is given, battery capacity is 75 kilowatt hour. This is nothing but this 75,000 watt hour. So 75,000 divided by weight is 500 kg. 500 kg. So this 0 is cancelled and this is the 150. Now this weight we measure in kg and energy is measured in watt hour. So as usual we get watt hour per kg. In question is also given measure in watt hour per kg. Now second, determine the power density of the battery in watt kg when delivering the maximum power. So power density second. This is the first, this is the second. So power density is equal to power divided by weight. Now in this question not directly power is given, capacity is given, weight, voltage and the current is given, but power is not mentioned anywhere. So we calculate first the power. So how to calculate this power? By using the formula V into I. Power is nothing but the V into I, voltage into current, divided by this weight. So voltage is given here 400 volt and the current is 200 ampere. So 400 divided by 200 into 200 divided by 500. 2 get cancelled, 5 ones are 5, 5 8s are 0, then it get 160. And power is measured in watt and weight is measured in kg. So in watt per kg we measure this power density. Now the third. So the third we calculate the C rate when the battery is discharging at the maximum current. So formula for the C rate is, this is the third number, C rate is equal to current divided by AH rating. Now we know only current is given here, maximum discharge current, but what about this AH rating? So formula for calculate this AH rating is equal to energy divided by voltage. So energies we calculate are here given, the capacity is 75,000 watt hour. So 75,000 divided by voltage. Voltage is 400 watt volt. So 400. So this is nothing but the 187.5. Now put this AH rating here. So C rate is equal to current is 200 divided by this AH rate 187.5. So this is nothing but the 1.067. So I hope all you get idea about the C rate also. Now the last question is, if the vehicle consumes 200 kilowatt on average while driving, calculate how long the vehicle can run fully charged battery. So we know the formula, energy is nothing but the power into time. Now we want to calculate time. So time is equal to energy divided by power. So time is nothing but how the vehicle run during the discharge the battery. So we calculate by this using formula. So energy is given, the capacity is 75,000 watt hour. So 75,000 3 divided by this power. Now this power is, consider this 20 kilowatt, because here mention the power, average power. So it is 20 kilowatt. So 20 kilowatt is nothing but the 20,000 watt. So this 20,000 watt to 3. So when we calculate this, we get 3.75. So this is the fourth sub question. How long the vehicle run? 3.75 hour. So 75 hours, 3.75 hours. You change or you convert into minute also and second also. Only multiply by the 60. So I hope all you get idea about this question as well. So next question is, a zinc chloride battery with a nominal voltage is 1.2 volt. We write here given. So given is, first, nominal voltage is equal to 1.2 volt. Capacity is 2200 milliampere hour. Second, capacity, this is the capacity of the battery, which is 2200 milliampere hour. We converted the milliampere hour into ampere hour simply. So 2200 into 10 raised to minus 3. So this is nothing but the 2.2 ampere hour. So we convert this 2200 milliampere into ampere hour, which is nothing but the 2.2. Then the next question is connected to a load that draw the constant power of 1.8 watt. So power is third, power is equal to 1.8 watt. Determine how long the battery will supply the power to a load before being fully discharged. Assuming the battery efficiency is 87%. So fourth is efficiency, which is 87%, which is nothing but the 0.0787. Now, as usual, I hope you all get the idea how we calculate how long the battery run or vehicle run. The formula is, first, energy is equal to power into time, and how we calculate time? By the energy divided by power. So if we see here, then the capacity is given in ampere hour, but most of energy we calculate in watt hour. So this ampere hour first we converted into watt hour, and then we put this energy as our input. So first we convert this 2.2 ampere hour into watt hour. So this watt capacity in watt hour, city in watt hour is equal to this ampere hour into nominal voltage into efficiency. So this ampere hour is 2.2 into nominal voltage is 1.2 into efficiency is 0.87. So the answer is 2.2968. So now this watt hour. So this capacity in watt hour we use in our formula. So now how long vehicle is run? Means time is equal to energy divided by power. Now this energy we calculate here in watt hour, because this capacity is always given in watt hour. So this 2.2968 divided by this power. So power is 1.8 watt. 1.8 watt. This is watt hour. So this watt is cancelled, and the answer is 1.2760 hours. So the vehicle is run 1.276 hours. We see one more example in a different form. So here we calculate in this video total 4 different types of the numerical based on the battery. So this is the last type of the question. So here the ultra capacitor of 1000 Faraday and operates across a voltage is 2.7. Calculate the energy stored in the ultra capacitor. So simply the formula for the energy stored in ultra capacitor is E is equal to 1/2 CV square. So this C is nothing but this 1000 Faraday charge. So 1/2, this C is nothing but 1000 Faraday into V. V is voltage, 2.7 square. So when we calculate this 3645 joule. So this 3645 joule energy stored in our ultra capacitor. So I hope all you get idea about all the types of the battery numericals. Now if any query or doubt, then let me know in the comment box. Thank you.